So now I hope now visibility is more clear. Satam. Okay. Now, if we talk about force, so what is force? Do you know what is force? All of you, any push or pull bring change, bring change in position, bring change in position of object, right? What is force? Any push or pull bring change in position of object or or change in position, change in position due to due to any push or pull, right? Its formula is it is F is equal to m into a, right? Where if m is mass and a is acceleration, acceleration. What is acceleration? Acceleration. Huh? Whose rate of change of momentum कहाँ से आ गया? Anyway, rate of change of velocity. Very nice. Rate of change of velocity is known as acceleration, right? And it is a scalar quantity. It is a scalar quantity, right? And mass is vector. Oh, sorry. Acceleration is a vector quantity. Sorry, it is a vector quantity, and mass is a scalar quantity. Scalar. तो ये फोर्स क्या होता है? फोर्स इज ए वेक्टर क्वांटिटी, राइट? मतलब व्हाट इज वेक्टर? वेक्टर मीन्स मैग्नीट्यूड, मैग्नीट्यूड, फिजिकल यूनिट, and direction, right? These three things are required. Yes, direction, right? Magnitude, physical unit, and direction. These three things are required. So, as force is m into a, so its unit is F is equal to kilogram into acceleration is meter per second square, right? It is kilogram meter per second square. It is also known as Newton, right? It is also known as Newton, right? Should I rub this? You are writing? Yeah. You take a screenshot of this. Okay. Because this is, I'm going a little bit from backside. It is very elementary. One thing is, as I told you, 1 Newton is equal to 1 kilogram meter per second square, and 1 kilogram is having 1000 gram, right? And 1 meter is equal to 100 centimeter per second square. So we can say that it is 1 lakh gram centimeter per second square, or we can say 10 raised to the power 5 dyne, right? In CGS system, gram centimeter per second square is known as dyne. So it is dyne. So 1 Newton is equal to 10 to the power 5 dyne, right? Now, if you keep this always in your mind, that 1 kgf 1 kgf is kilogram force is equal to 10 Newton, right? 1 kgf is equal to 10 Newton, where g is 10 meter per second square, right? And it will be 9.8 Newton, 9.8 Newton if g is 9.8 meter per second square. Fine. This is. You should also keep in mind that 1 Newton is equal to 0.1 sorry 0.1 kgf, right? 1 Newton is equal to 0.1 kgf or 100 gf. This is kilogram force, this is gram force, right? All you have written? Okay. Pratham, done. Vinod, okay. I'm going to run. Now we are going to talk about, basically in this syllabus you have that is known as moment of force. You have moment of force, right? Moment of force, it is also known as torque, right? Torque. What is torque? Torque is turning effect. Turning effect. That is known as torque, right? If if you are having a wheel like this, right, and you are putting a force, the force is in this. Oh my god. This force is in this direction. This force is in this direction. So what is it? What is the direction of force? It is, yes, very small. Anti-clockwise. This is anti-clockwise. When it is anti-clockwise, then it is positive, right? And similarly, when it is in clock, like it is in it is, yeah, it is like coming like this and this. So this is clockwise, right? Clockwise, then we say negative. right? And this tau, tau is like this. This is known as tau. Okay, we call it tau. Tau is torque or moment of force, right? Uh, say this is a wall, right? And there is a door, right? So this is the fixed end. Around this is the fixed end, and your door is rotating about this axis, right? If you put force like out towards this side, you put force, then it will rotate. How? It will rotate like this, right? So this is the axis of rotation. इसको हम क्या बोलते हैं? This is called axis of rotation. Axis of rotation. This is axis of rotation and a fixed end, and this is the point we are applying force, right? So torque or turning effect, tau is equal to F into D, right? Tau is depending upon F into D. F is force and D is equal D is equal to perpendicular perpendicular distance, right, from point of application of force, point of application of force, right? I hope you understand. This is axis of rotation. This is point of force. So D is perpendicular distance between force and axis of rotation, and force is, so tau is product of force into perpendicular distance between point of application of force. It should be perpendicular distance. Fine. I'm every time stressing that perpendicular distance. Anyway, so this is the tau, and it causes turning effect, right? Then its unit is, so tau, the tau unit is force into D. It means Newton meter. Its unit is Newton meter. SI unit is Newton meter, right? Okay. Should I rub? Okay. As I told you, uh, tau is tau is directly proportional to force and tau is directly proportional to distance, perpendicular distance, right? So tau is directly proportional to F into D. If we take a constant, that is tau is equal to k is a constant, its value is 1. So F into D, so where k is equal to constant, its value is 1. So we can write tau is equal to F into D, right? So you know, as much as distance between point of application of force and axis of rotation, you have to apply less force, right? As much as distance. That's why you have seen that he in your doors the handle is always on one end, right? And the fixed point is here, right? Or if you want to put close, if you wa- if you put force on the edge of the door, it is easily going to be closed, right? अगर आप डोर को एकदम उसके एज पे फोर्स लगाते हो तो आपको लेस फोर्स लगाना होता है, और अगर उसके जितना क्लोज लगाओगे, जितना एक्सिस ऑफ रोटेशन के क्लोज फोर्स लगाओगे, उतना ज्यादा लगाना पड़ेगा आपको, है ना? तो इसीलिए कई बार आप, है ना, सो दिस इज व्हाट वी हैव, एंड दैट्स व्हाई जो स्पैनर होते हैं, स्पैनर समझते हो, जो बोर्ड्स को खोलने के लिए जो हम यूज करते हैं इंस्ट्रूमेंट, उसको स्पैनर बोलते हैं ना, लाइक दिस। तो उसका हैंडल थोड़ा बड़ा होता है, जितना बड़ा हैंडल होगा, क्योंकि बोल्ट यहाँ पे होगा, है ना, बोल्ट यहाँ पे होगा, आप फोर्स यहाँ से लगाओगे तो ये एक्सिस ऑफ रोटेशन हो गया, ये हो गया एक्सिस ऑफ रोटेशन, और ये हो गया पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स। अब डिस्टेंस जितना ज्यादा होगा, फोर्स उतना कम लगाएंगे हम, है ना? तो स्पैनर थोड़े से बड़े रखे जाते हैं, उसका बड़ा रखा जाता है। जैक में भी आप देखोगे, जैक का जो हैंडल होता है वो कोशिश की जाती है, जैसे मान लो ये आपका अगर जैक है, राइट, तो जो होते हैं वो उसको यहाँ पे पहले फिक्स करते हैं, उसके बाद फिर यहाँ से एक हैंडल लगा के और बड़ा कर लेते हैं उसको, जिससे कि जितना ज्यादा डिस्टेंस, ये डिस्टेंस जो 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 इसका रिजल्टेंट डिस्टेंस हो गया ये, और डिस्टेंस जितना ज्यादा होगा, फोर्स उतना कम लगाना पड़ेगा आपको उसको रोटेट करने के लिए, है ना? तो दिस इज ये हमारा जैक होता है। तो दीज आर द एप्लीकेशंस ऑफ टॉर्क, ठीक है? टॉर्क में जैक में हो गया, स्पैनर में, है ना? एंड दीज आर द डोर्स। डोर्स में हिंज और हैंडल के बीच डिस्टेंस बहुत ज्यादा रखा जाता है, बिकॉज वी हैव टू अप्लाई लेस फोर्स। गेट इट? ओके, नाउ देयर इज, should I love? Okay, now, so now we have moment of couple, right? Moment of couple क्या हुआ? Moment of couple, इसमें क्या है, जैसे एक फोर्स आप इस पॉइंट पे लगा रहे हो, ए पॉइंट पे, और एक फोर्स आप बी पॉइंट पे लगा रहे हो, इस पे भी इधर की तरफ फोर्स लगा रहे हो, दिस इज इन क्लॉकवाइज एंड दिस इज आल्सो इन क्लॉकवाइज, राइट? दोनों तरफ फोर्स सेम है, इधर भी 5 न्यूटन का फोर्स है, इधर भी 5 न्यूटन का फोर्स है इन क्लॉकवाइज डायरेक्शन, राइट? तो इसके बीच इनका जो सेंटर होगा वो ये होगा, है ना? एक्सिस ऑफ रोटेशन जो हो गई वो ये हो गई, है ना? दिस इज एक्सिस ऑफ रोटेशन एंड दिस इज पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स। अगर इनके बीच का डिस्टेंस L है, ये L है, ये भी L है, तो जो मोमेंट ऑफ कपल होता है, मोमेंट ऑफ कपल, मोमेंट ऑफ कपल is equal to total distance, total distance, distance between two forces into any one effective force, right? So this is equal to 2L into F, right? F, yeah, F is equal to F into 2L is equal to moment of couple. Is this written in your book? Right? So any one effective force into total distance between them. Total L plus L becomes 2L. So I have written here 2L, and one effective force is F. So I have written here F. Both sides same force is acting. Right? I hope you understand. This is moment. This is moment of couple. Now we are going to talk about. Now we are going to talk about equilibrium. What is equilibrium? Do you have any idea? Since this is you, right? And and one of your friend is stretching you towards this side, and another friend is another friend is stretching you towards this side, right? Both are applying same force, say 2 Newton. Both are applying 2 Newton force. Then what will be your change in position? Oh. Ah, this red color marker? Okay, okay, okay. This is the one friend. This is the another friend, right? It is pulling you towards this side with the force of 2 Newton, and here it is stretching you towards with the force of 2 Newton. So what will be change in your position? This is huh? Huh? नहीं, मैं सिर्फ इतना कह रहा हूं कि यू आर दिस one of your friend is one of your friend is pulling you to with a force of 2 Newton towards this side, and one is pulling you towards this side. So what will be your position? There is no change in position. No change. No change. Right? So it means you will be in a state of equilibrium. You will be you will be in a state of equilibrium, right? Equilibrium in normal life. Hello? इक्विलिब्रियम मीन्स व्हेन जितने भी टॉर्क लग रहे हैं उन सब का सम जीरो होना चाहिए। अगर 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 एक ऑब्जेक्ट पे जितने भी टॉर्क हैं उन सब का सम जीरो है, अलजेब्रिक सम जीरो है, तो वो ऑब्जेक्ट इक्विलिब्रियम में जहां है वहीं बना रहेगा और जैसा है वैसा ही रहेगा, राइट। सो इक्विलिब्रियम इज स्टेबल कंडीशन या स्टेट ऑफ नो चेंज, राइट। So what is equilibrium? Equilibrium in state of equilibrium, in state of equilibrium, no change, no change in position, right? Or algebraic sum, algebraic sum, algebraic sum of all forces, all forces, all taus, moment, all moment of force, all torque, say torque, is zero, right? Then object is said to be in a state of equilibrium, right? Now the equilibrium is of two types. Equilibrium is of two types. One is called static equilibrium. Static equilibrium. Equilibrium, right? Static equilibrium, and another one is dynamic equilibrium. Dynamic equilibrium. Static equilibrium means when object is in rest, object in rest, then then tends to be tends to be in state of rest. Getting visible what I am writing? Object in rest tends to be in state of rest. Then it is known as static equilibrium, right? And dynamic equilibrium is when when object is in motion, when object is in motion, then tends to be tends to be in a state of motion. I hope you understand. So what I said that when algebraic sum of all taus is zero, then object is said to be in equilibrium, or sum of all forces acting on an object is zero, then object is in state of equilibrium, right? And now, or you can say, or sum of all algebraic sum of all forces. Algebraic sum of all forces is 0, then in equilibrium. Is it visible? Equilibrium, right? And it is of two types. One is static, another one is dynamic. Static equilibrium, when object is in rest, then tends to be in state of rest, and dynamic, when in motion, then tends to be in state of motion, right? I hope this much is written in your book. Okay. Now, should I rub this? Huh? Pardon? You need example. Dynamic equilibrium. Like this car. This is the car, right? It is moving, right? So it is moving. So it keep on moving unless until, but due to friction, due to friction, due to friction, it it get stopped, get stopped. But it during motion to come from moving state to rest, it covers some distance. If you apply brake on a car, it does not immediately stops. Did it happens? What? Yes, sir. When you apply brakes, it immediately stops. It takes some time. It travels it travels some distance. In the meantime, since friction is working there, suppose it is if smooth if there is a smooth surface, when then you slip down. So you slip, then you have, for stopping you have to you have to do some work. Some friction is working, right? So that's why if there is no friction, you keep on moving. Getting? So friction, no doubt in nature, friction is a force which is everywhere available, right? So, but if we talk about zero gravity, then what happens? Second pendulum means, do you mean no? Second pendulum means it takes 2 seconds to complete one oscillation, right? Or you can say, or we can talk about free vibrations. Free vibration means when object is start oscillating, it keep on oscillating because no external force is applied on it, right? So that is what dynamic equilibrium. When there is no external forces acting, so it keep on doing. It tends to be keep on moving. And first of all, this car is moving, you are applying brakes due to friction, it gets stopped, but it generates heats. It tires gets heated. Right? Why it is heated? Heated because there is some work is done against to make it stop. Some mechanical work is done, so that's why that heat get generated. When your car or your bicycle is when you are when you are moving with bicycle, after some time when you touch that, when you come to your home from school, you come to home and you touch that the wheel of your bicycle, you see they get heated. Why they get heated? Due to the friction between applied offered by the road on your wheels of your bicycle, right? Since you are applying force, and because of force, and your force is greater than the friction. If your force will be less than friction, then your bicycle will not move. Hello, you know who asked me examples? Pratham. अच्छा, ये तो डायनेमिक, वेरी नाइस. ठीक है, अभी अभी मिल गया एग्जांपल. ठीक. So another one is another is you know there is principle of movement. This is very important and that will come in your exam. Principle of movement, right? Principle, स्पेलिंग सही है? No. Principle, ये वाला सही है प्रिंसिपल, ये वाला प्रिंसिपल सही है? Principle of movement, right? What is it? What is principle of movement? That is sum of all anti-clockwise tau, anti-clockwise anti-clockwise tau is equal to sum of all anti-clockwise taus is equal to sum of all clockwise taus, right? This is principle of movement. And one thing you keep, that weight of an object, weight weight of an object is always at its geometric center. Geometric center. Did you understand the meaning of this? Weight of an object is always on its geometric center. Means if there is a meter scale समझते हो? 1 meter is having 100 centimeter, right? So this is a meter scale. It is starting from 0 and coming to from 200, right? So its weight will be at 50 centimeter. Its weight will be on 50 centimeter. Weight of scale. क्यों? क्योंकि this is the geometric center of this meter scale. Weight of meter scale, right? If suppose you are putting a fulcrum here, if you are putting a fulcrum here on 40 centimeter mark, on 40 centimeter mark, right? Then to balance it, huh? No, it is definitely it is not balanced. So if distance is x1 into weight is w1, and if we put another weight here of w2 value and distance is x2, right? Then if it is in equilibrium, if it is in a state of balance, in a state of balance, in a state of balance by principle of moment, by principle of moment, by principle of moment, product of w2 into x2 is equal to w1 into x1, right? Then only this meter scale will be in a balanced condition. If they are not equal, then it is not in balance. It will tilt towards on on which side tau is more. This is tau na? This is tau. Force into displacement is tau. Force into distance. This is tau 2 is equal to tau 1. I hope you understand. All of you. Okay. What I said here, this is a meter scale. Right? Meter scale means in 1 meter there is 100 centimeter, right? So 50 centimeter will be its geometric center. So weight of meter scale will be at 50 centimeter. If you put a fulcrum, right? Fulcrum means a point of balance. If you put a point of balance at 40 centimeter, so to bring this scale in a balanced condition that it not get tilted, we have to apply a weight on x2 distance, right? If this 40 to 50 is x1, then this distance will be x2, and w2 into x2, force into distance is known as tau. W is what? Weight is a kind of a force. So force into displacement d is equal to tau, and this is also tau. This is tau 2, this is tau 1. So tau 1 and tau 2 are equal. This is known as principle of moment. Okay? I hope this much is in your section, right? This much in your this section. In second section in your book is what I said you here. Weight of an object is always at its geometric center. किसी भी ऑब्जेक्ट का वेट जो होता है वो उसके ज्योमेट्रिक सेंटर पे होता है, ठीक है? अगर आप एक पेंसिल को, अगर ये पेंसिल है तो इसका जो ज्योमेट्रिक सेंटर होगा वो उसके हाफ पे होगा, मतलब ये जो सिलेंडर है इसका जो एग्जैक्ट हाफ होगा वहां पे होगा, ठीक है, किसी भी चीज का जो होता है तो वो आपकी बुक में लिखा है, वो आप याद कर लेना, जो ना समझ में आए मेरे से पूछ लेना। ठीक है, वैसे उसमें कुछ दिमाग नहीं लगाना है, कुछ दिमाग नहीं लगाना है। जैसे कि इक्विलेटरल ट्रायंगल का जो ज्योमेट्रिक सेंटर होता है, वो उसके जहां पे भी तीनों मीडियन मिलते हैं उसके सेंट्रॉइड पे होता है। ठीक है, अगर एक रेक्टेंगल है, एक स्क्वायर है, तो उसका जो ज्योमेट्रिक सेंटर होता है वो उसके डायगोनल जहां पे इंटरसेक्ट करते हैं वो होता है उसका ज्योमेट्रिक सेंटर। ठीक है, अगर एक अगर एक स्फीयर है तो वो उसका ज्योमेट्रिक सेंटर जो होता है वो उसके सर्कुलर एंड के सेंटर में होता है। रिंग का जो सेंटर होता है वो भी उसके स्पेस में, मतलब आउटसाइड बॉडी इन द सेंटर ऑफ दैट रिंग, लाइक दिस इज द रिंग, राइट। तो इसका जो जो सेंटर होगा वो इसके ज्योमेट्रिक सेंटर यहाँ पे होगा। ठीक है ना। So this is the statement for all your second section. ठीक है, you just read it, it's very simple, you just read it. If you still not understand it, is able to stand, I'll explain you. Now you have third section in your book, that is called uniform circular motion. Third section in your book. Ready? So this is a circular path, this is an object moving on circular path। ठीक है, so if an object if an object is moving on a circular path with uniform uniform speed, right? Uniform speed is a scalar quantity. Then object said to be in state of uniform circular motion, uniform circular motion। Getting? If an object is moving on a circular path with uniform speed, then object is said to be in a state of uniform circular motion. If we talk about velocity, velocity is displacement upon time, displacement upon time, right? If 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 initial and final positions, if initial and final positions are same, then displacement is sorry displacement is 0, right? So every one cycle, after completing one circular, one revolution, its velocity going to be 0, right? But but velocity is a vector quantity. Vector quantity, तो vector quantity में along with magnitude and physical unit, direction is very important, right? So when it is moving on a circular path, if it starts from here, so from here it will having a different velocity, right? From here it will have different velocity. From here it will have different velocity, and when it reaches here, then velocity will zero. So its velocity is changing during the time. Velocity is changing means its direction is changing. Its direction is changing, so its velocity is changing. So that's why so that's why circular motion is also known as accelerated motion. What? So circular motion, because velocity is magnitude wise it's going to be zero, but during the time of revolution, at every moment of time, its direction goes change. Its direction going to be changed. So it is in accelerated condition. So that's why circular motion, circular motion, circular motion also known as accelerated motion. Hello, getting all of you understand me what I said? अगर यूनिफॉर्म वेलोसिटी से मूव कर रहा है, क्योंकि स्पीड एक स्केलर क्वांटिटी है, तो उसको बोलते हैं यूनिफॉर्म सर्कुलर मोशन। लेकिन वेलोसिटी जो है वेक्टर क्वांटिटी है और डिस्प्लेसमेंट के ऊपर डिपेंड करती है। इनिशियल एंड फाइनल पोजीशन अगर सेम होंगी तो डिस्प्लेसमेंट जीरो हो जाएगा, देन वेलोसिटी इज गोइंग टू बी जीरो। बट पॉइंट इज दैट की वेलोसिटी इज a vector quantity also, so every point of time its direction is changing, it means velocity is changing. So change in velocity, rate of change of velocity is known as acceleration. So a circular motion is also known as accelerated motion. I hope you understand. Okay. Now one more thing is, should I rub this? Okay. Okay. Pratham, you are getting? कुछ पूछ रहा है? Any type of worm is moving in your mind? नहीं? All clear? Pratham, all clear? It means always. This definitely it is all clear. What is the meaning of all clear? All clear means all clear. Anyway, okay. अभी क्या है कि फिर से हम बात करते हैं, जब कोई ऑब्जेक्ट सर्कुलर पाथ पे मूव करता है, राइट? जब जब भी कोई ऑब्जेक्ट सर्कुलर पाथ पे मूव करता है तो क्या होता है? दिस इज द सेंटर ऑफ सर्कुलर पाथ, राइट? ऑब्जेक्ट इज मूविंग हेयर, प्रथम, ओके? ये सेंटर है सर्कुलर पाथ का, ये ऑब्जेक्ट है, ठीक है? तो यहां से यहां तक का डिस्टेंस क्या होगा? आर, रेडियस, इस ऑब्जेक्ट का कुछ मास रहा होगा, दैट इज कॉल्ड एम, और जब ये मूव कर रहा है तो इसकी कोई वेलोसिटी होगी, दैट इज कॉल्ड वी। ठीक है, तो जब कोई ऑब्जेक्ट सर्कुलर पाथ पे मूव करता है तो दो तरह के फोर्स लगते हैं। ठीक है, वन फोर्स इज टूवर्ड्स द सेंटर, टूवर्ड्स द सेंटर, it is called center seeking force, center seeking force, right? What I said, there are two, this object is moving on a circular path, one force is acting towards center, that is called center seeking, और इसको बोलते हैं centripetal force, centripetal force. Your voice is coming very slow, Pratham. What happens? Wi-Fi is not working, so is it visible to you what I am trying to say? हो बड़ी समस्या है ये तो भाई। एनीवे, ठीक है, तो ये हो गया सेंट्रीपिटल फोर्स। एंड सेंट्रीपिटल फोर्स का जो फार्मूला होता है दैट इज एफ इज इक्वल टू एम वी स्क्वायर अपॉन आर, राइट? You just keep in your mind. It is not in your syllabus in 10th. We will do, further we will talk in class 11. You just keep in mind that F is equal to mv square upon r. This is centripetal force, right? And another force is acting towards outside, towards the center, and it is away from center, away, away from center. It is called it, uh, centrifugal force. Very small. Centrifugal force. Centrifugal force, right? Because of that, because of this centripetal force and centrifugal force, object moves in a tangential direction. टेंजेंटल डायरेक्शन समझते हो? टेंजेंट मतलब ये इस तरफ जाएगा, जब ये यहाँ पहुंचेगा तो ये इस तरफ जाएगा, है ना? जब ये यहाँ पहुंचेगा तो ये इस तरफ जाएगा, ठीक? Always tangential direction में, because these two forces are acting and they both keep the object in balance, है ना? You have seen, if you tie the stone on one end of a thread and you start rotating it, then what happens? You have to apply a force to keep it moving on a circular path, right? Your hand will feel a force, प्रथम, है ना? हाँ, so you will feel a force on a circular path. So this is what we have. But these two forces do not obey Newton's third law. Do you know what is Newton's third law? These two forces, these two forces, these two forces, centripetal force, centripetal force, and centrifugal force, centrifugal force, right? क्या बोला था मैंने? These two forces, centripetal force and centrifugal force, do not obey, do not obey Newton's third law. Why? Because they they keep they keep in balance each other, right? Centripetal force इसको अंदर नहीं मतलब due to centripetal force it is not falling in on the center, and due to centrifugal force it is not going away from the center because they both keep एक दूसरे को they keep in balance and object move on a circular path. In spite of that, it is not obeying Newton's third law. Why? Do you know what is Newton's third law? हाँ हाँ बोलो। ओए रुक जा, एक मिनट। क्या नाम आद्रिका, एक मिनट रुकना, इसको बोलने दो। हाँ बोलो बोलो, वेरी नाइस। हाँ, every action is having a reaction which is equal in magnitude and opposite in direction. So here is having equal in magnitude, opposite in direction. That's why they are in balance, but still they are not obeying Newton's third law. Why it is? प्रथम कुछ दिमाग काम करता है तो क्यों ऐसा नहीं हो रहा है? You are saying it is Newton's third law. Every action is having a reaction. You said every action, every action is having, every action is having reaction, right? Which is which is equal in magnitude, equal in magnitude, but opposite in direction. But still they are, these opposite in direction, but still they are not. Why it is? Because these two forces, these जो आपने कहा ना, every action is having a reaction which is equal in opposite but opposite in direction. So between two different objects, between two different objects, two different objects, right? But these two forces are acting on one object only. These two forces are acting on one object only, right? So they are not obeying Newton's third law. I hope that, हाँ? यार तुम जो मैं पूछ रहा हूँ वो तो बता नहीं रहे, तुम आगे जा रहे हो यार, ये गलत बात है। तो बात तो ये पहले इस पे आओ ना। नहीं, योर एरिया ऑफ नॉलेज इज मोर देन मी। मतलब मुझे लग रहा है कुछ दिनों बाद यू शुड टीच मी, राइट? अभी जो मैंने बताया ये समझ में आया पहले? नहीं, यू आर करेक्ट, यू आर करेक्ट, तुमने सही बोला है एकदम। जो बोला है सही बोला है, जहां से भी बोला है। सेंट्रीफ्यूगल फोर्स जो होता है वो स्यूडो फोर्स होता है। स्यूडो समझते हो ना? स्यूडो मतलब कि इट इज जस्ट ए फीलिंग, राइट? आई अंडरस्टैंड, आई अप्रिशिएट यू। बट अभी हम जिसकी बात कर रहे हैं ये पॉइंट तुमको याद रखना, दिस पॉइंट यू शुड रिमेंबर, इट इज वेरी इंपॉर्टेंट। Centripetal force and centrifugal force are both force, but they are also equal and opposite forces, but they do not obey Newton's third law, because Newton's third law में the force between two objects होना चाहिए, and here they both are acting on one object. So that's why it is not. And you are certainly correct that centrifugal force is a pseudo force. Your knowledge is very good. कौन सा वीडियो देख रहे हो? क्या स्कूल में बताया? तो स्कूल में ये नहीं बताया था कि ये दोनों एक ही ऑब्जेक्ट पे लग रहे हैं इसलिए ये न्यूटन थर्ड लॉ को ओबे नहीं करते हैं? हैं? अभी एकदम क्लियर हो गया ना दोनों? ये क्वेश्चन, दिस क्वेश्चन 100% कम्स इन योर एग्जाम. This question I can give you in writing that during your जो आपके बीच में एग्जाम होंगे, evaluation up to pre board, this question definitely come once or twice. ठीक है? तो प्रथम को समझ में आया तो थैंक यू वेरी मच. एंड तुमने मुझे बताया कि ये pseudo force होती है. आई एम थैंक यू फॉर दैट. आई वाज नॉट अवेयर. ठीक है? It is a pseudo force. So centrifugal force is a pseudo force. ठीक है? वेरी नाइस. सो ये हो गया. अभी क्या है, जब आप किसी ऑब्जेक्ट को छोड़ते, अगर हम फोर्स लगाना, ये फोर्स अगर हम हटा लेते हैं तो ऑब्जेक्ट जो है वो टेंजेंटियल डायरेक्शन में जाता है. आपने देखा होगा अगर किसी ऑब्जेक्ट को आप सर्कुलर पाथ पे ऐसे घुमाते हो तो घुमाते घुमाते जब छोड़ते हो तो वो क्या होता है, जिस पॉइंट पे होता है वो उसके टेंजेंटियल डायरेक्शन में जाता है ना? जैसे जैसे ये अगर सर्कुलर पाथ पे घूम रहा है, आपने इधर से इसको पकड़ रखा है मान लो धागे से, और ऐसे ये है, और जब आप इसको छोड़ोगे तो ये इधर की तरफ भगेगा, या अगर ये यहाँ होगा तो ये इधर की तरफ भगेगा, है ना? ये होता है, ये पूरा तुम्हारा यूनिफॉर्म सर्कुलर मोशन हो गया. यूनिफॉर्म सर्कुलर मोशन इज व्हेन ऑब्जेक्ट इज मूविंग विद यूनिफॉर्म स्पीड and when and circular motion is also known as accelerated motion because every point of time velocity is changing, right? Not in magnitude but in direction. So that's why it is called accelerated motion, right? I hope this much is in your chapter. All the important points I have covered. Anything is left? Huh? Uniform medium. Oh, yes, there was something. I have to go a little bit. Should I rub this? Okay. Okay. So, uniform, linear motion ना, उसको बोलते हैं, जैसे अगर एक ऑब्जेक्ट है तो इसके दो पोजीशन होते हैं, दो मोशन होते हैं. एक मोशन जो होता है, मोशन when when all the points all the points all the points of object moving 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 equal distance equal distance equal distance in equal time interval equal time interval. ठीक है? क्या बोला मैंने? When all the points of object moving equal distance in equal time interval, right? जैसे आपका कार होता है ना, कार में ऑल द व्हील्स, फोर व्हील्स ऑफ कार आर मूविंग विद सेम स्पीड इन सेम डायरेक्शन। या ऐसा होता है कि फ्रंट व्हील इज मूविंग इन फॉरवर्ड एंड रियर व्हील्स आर मूविंग ऑन बैकवर्ड। इट हैपेंस लाइक दिस। क्या? यस सर। अगर एक कार है तो कार का ये फ्रंट, ये इसके फ्रंट व्हील हो गए, ये रियर हो गए, तो ऐसा होता है क्या कि इसके इसके फ्रंट व्हील जो है वो इधर की तरफ जा रहे हैं और रियर व्हील इधर की तरफ जा रहे हैं, ऐसा होता है? यस सर। यस सर। यस सर। इज इट? नहीं, ऐसा होता है कि ये सब एक ही डायरेक्शन में चल रहे होते हैं, है ना? इसको बोलते हैं रेक्टिलिनियर मोशन। रेक्टिलिनियर, sorry, it is called translatory motion. It is called translatory motion. Sorry, translatory motion. ठीक है? When all the points of an object is moving in say मतलब equal distance in equal time interval in same direction. मैंने कहाँ लिखा यार? When all the points of an object moving equal distance in equal time interval in same direction, in same direction, right? Then it is called translatory motion. Translatory motion is two types. One on a straight line, move on. Who is gone? Hello. Yeah. So on a straight on, on a straight line, it is called rectilinear motion. Rectilinear motion, right? And when on a straight line, and when on curve path, then called curvilinear. कर्विलिनियर। ठीक है? एक दूसरे तरह का मोशन एक होता है रोटेटरी मोशन। रोटेटरी रोटेटरी मोशन, राइट? अबाउट एन एक्सिस, अबाउट एन अबाउट एन एक्सिस। फिर होता है ऑसिलेटरी मोशन। ऑसिलेटरी मोशन क्या होता है? टू एंड फ्रो मूवमेंट, टू एंड फ्रो मूवमेंट, मूवमेंट about a mean position, about a mean position। ठीक है? सही है? And any other type of motion? हेलो? हाँ, any other type of motion? What is that? That is called, one is periodic motion, है ना? Periodic motion, repeating position after a fixed interval of time, repeating position after after a fixed interval of time. Do all you understand? Periodic motion means repeating position after a fixed interval of time. जैसे ऑसिलेटरी मोशन इज ए टाइप ऑफ पीरियोडिक मोशन. ऑसिलेटरी मोशन में क्या होता है, जैसे ये पेंडुलम है, तो ये इधर की तरफ जाएगा, फिर ये इधर की तरफ आएगा, फिर ये इधर की तरफ जाएगा, एंड देन इट कम बैक टू इट्स मीन पोजीशन. It is going towards left, from left, then coming back to the center, mean position, then going towards right and coming back to its mean position. That it is periodic motion, right? Earth rotates, you know, Earth, this is sun, this is Earth. Earth rotates on a periodic, it takes on after 365 days, 5 hours, 46 minutes, and in 46 seconds it completes one rotation. It reaches to its initial position. So this is periodic motion. And a moon revolves in how much time around the earth? Moon rotates around the earth in how many days? Adrika, Sigon? Good. Oh, everyone is still drop silence. Yeah, it is 27 days. It takes 20, and if, point is that it takes 27 days to rotate around the earth, and it takes 27 days in rotating about its axis also. Getting my point? What I said? I said 27 days to rotate about the earth, and at same time 27 days to rotate about its axis. Like Earth is taking 365 days, 5 hours, 46 minutes and 46 seconds to rotate about around the sun. But on its axis, it takes 24 hours. Right? So that is the difference in Moon and Earth. I hope you people enjoyed. Where is Pratham? Pratham, all clear? Hmm. हो गया क्लियर, मैं समझ गया. ठीक. So I hope this chapter is over. all the all the major topics, all the major points and topics I discussed, which are going to be asked in your exams, right? In spite of that, you go through with your book. If you find anything I missed, I can tell you about that. Okay? So